Hello, Pradeep. I am audible.
Yes, sir, audible.
Okay, we'll start within 5 minutes. Let us
Yeah,
wait for
sure.
another.
Yeah, yeah.
Hello, I'm audible.
Yes, yes, sir.
Okay, okay, we'll start today with a new week. That is the week 12. That is the last week. But I will take another session. That is the extension one, and that is I think on Friday. On Friday from 6:30 to 8:30, and on Friday, the coming Friday, just coming Friday, and on that day I will take the drag and lift part. So today we'll see some basically the week 12, the introduction of the open channel flow. The lecture 1 was about the open channel flow first, and lecture 2 was open channel flow second, and open channel flow third in the lecture 3. And the lecture 4 I will take in the extension session. So today what we do, today we'll solve some problems, that is the previous year questions. Previous year only this your previous year actually assignment question of the NPTEL fluid mechanics. So you know the open channel flow already. What is the open channel flow? Just open channel flow is, let me take the pen. Okay, as we see the open channel flow, just as a name suggests, what is open channel flow? Flow in open environment. Like you just take the example of river or canal, whatever, it flow in the open channel and having the free surface kind of thing, or you can say the pipe flow with some, that is the atmospheric pressure is here and atmospheric pressure is here. Now, and flow under gravity, this is also important for that. So I think week 12 is done. And when uh, Pradeep, when is your exam, the final exam of this NPTEL course? Which date?
28th of October.
28, right? So we'll finish on 20, I think, on Friday. Which date? Okay. So, okay, we'll first solve one or two questions, then I will have some concepts regarding the open channel flow, very, very important concept. Then we'll move further on question. So the first question is visible.
Visible.
Okay. The first is about the calculate the weighted perimeter of a rectangular channel having top width 4.5 meter and depth 3 meter. Here is asking the weighted perimeter kind of thing. So please just solve the question and write your answer in the comment box. So the question is, if we draw the figure of question, what is written? They calculate the weighted perimeter. Okay, let's suppose we denote the weighted perimeter by PW. This is the question of a rectangular channel having top width, that is a rectangular channel is there. Let us suppose water is flowing up to that much. The top width is what? top width is around 4.5 meter and depth is 3 meter, right? What is weighted perimeter in this question? I think if you know the formula of perimeter, then you can calculate easily. Okay, the Francis is telling the option D is correct for the question first. Okay, what about your answer, Pradeep? You just tell your answer, then we'll check just whether the option D is correct or not. Okay, Pradeep is telling option B. Okay, let me check. The perimeter is nothing but if this is B and this is Y, the perimeter is nothing but the sum of weighted weighted part of this cross section. Which weighted part? This is also weighted with water, this one and this one, that is this height and this height, that is the 2 times of Y plus, and this is also weighted B, 2 into 3 plus what is B? B is 4.5 meter. So 2 3 is a 6, 4.5, that is 10.5 meter is the weighted perimeter of this question. So this is the whole idea of this question. So option D is correct. Pradeep, you are telling the option C. Where you have facing the problem, Pradeep? Just you tell.
So actually, it is. I think it is 10.5. Yeah, 10.5. I got 10.5.
Okay, okay, it's
Yeah,
okay, it's
yeah,
okay.
something wrong. Yeah.
Okay, and please, if you let me just extend this question. You know the hydraulic radius, hydraulic mean radius. You know these things.
Yes, sir. Yeah.
Okay, you just calculate for this question. What is the
Yeah.
hydraulic radius?
Yeah.
For question number one.
Minus 5, 6. 1.28. That is 1.23 something.
Okay, okay, let me check.
229. Yeah. 1.3. Yes, 1.29.
Okay, then how much? 3 into 4.5 divided by 10.5, right? Yeah, 1.28,
Yes.
1.28. So the unit of this, this is a unit having the meter square and this is a unit having the meter. So you got the unit of meter, right?
Yeah.
So if I write the formula of RH, then you will see what your B and Y. This is the concept only, and here 2Y plus B. If your channel is very wide, channel is wide means like B value is 3 kilometer and depth value is 2 meter. So if you compare these things, what will your B is very greater than Y, right? So in that case, we neglect this 2Y, and that is a very wide case of channel. So your RH is equal to nothing but B into Y, and we have neglected the 2Y. only remove here B. So some for your white channel we can consider Y in calculation. There is very negligible, or the difference between the 3 kilometer and 2 meter. So very negligible kind of, you can say, the not
In,
error, but
so in that case, it will be only 4.5. That means in
yes.
white channel, it is only 4.5 in that case. If it is white channel.
Yes, if it was a white channel, then you can say this is the your and the definition of white channel, let me tell here. This is also important. When your B is greater than Y, this is the also condition of the white channel. And sometimes that is given by Vanoni. Vanoni is telling, I think, 4 times. If your B is greater than 4 times of Y, then it is a white channel. Right? If you compare these things by this definition, if you compare these things by this definition, this is the white channel because B is greater than Y. But this is not a white channel, you cannot consider. If you compare by this definition, your B is how much? Your B was 4.5 meters, and it is greater than, whether it is greater than or not, let me check. 4 into 3, it is 12. This definition is wrong. So it is a narrow channel, right? So this type of, well, lots of definition is there, whether which actually which dimension ratio is the narrow and which dimension ratio is the wide channel. Why it is important? Let me take important thing I want to tell you. Why it is important, narrow channel and wide channel. Let me represent the graphically, then you can understand. So this is the narrow channel and this is the wide channel. So let us suppose this is B1, let me tell Y1, B2, and this is Y2. So if your channel is narrow, then what will happen? And the main type of stress we study in case of, that is the open channel, that is the resisting type of stress, that is the shear stress. The shear stress, that is the shear stress. In case of narrow channel, your shear stress may chance, that is the this wall shear stress, this wall shear stress, side wall shear stress may chance to affect your flow condition in the main channel. But in case of wide channel, your side wall, there is very negligible chance to, very minute chance to affect your main channel flow. So that's why we consider, in case of wide channel, your RH, we can consider this is Y only.
Sir, when will call this white channel? Like what is the condition? When will,
Yeah, basically the lots of definition is there, right? When you follow some book, that is the one researcher Vanoni, he is telling, if your, for this case, if your B2 is greater than 4 times of Y2, then we can say that this is the wide channel, right? But generally people is telling, if B is greater than Y, then you can also tell the wide channel kind of thing. But this is, as an engineer, because we are always try to apply it, science and whatever for the humankind, we cannot consider these things, because if your b like, let's suppose, a previous question, if your b is 4.5 meter and and y was 3 meter, then whether we can consider this wide channel or not. As an engineer, this is very difficult to say this is a wide channel, because it may chance to affect the flow dynamic of the main channel, right? So finally, if some question, if you sometimes you get the question, uh, whether this for wide condition, whether this condition is valid or not. So in the question, if option is there, there is no option, then you can correct this one. If option is there, this, and written the name of the Vanoni or the wide channel definition by Vanoni, then you can correct this one. And another scientist also, another researcher also given this type of for ratio of width and depth. So you go through, it's better to go through book and explore your knowledge on that. Right, I think Pradeep, you
Yes,
got
sir.
it.
That is.
Okay.
Yeah.
So is that actually four times Y2? You have written four times?
Yes, 4 times Y2.
Okay.
It was given by this. You search on Google, you can also get it. This type of.
Okay, sir. So in the hydraulic diameter, the formula is actually, can you say the formula of hydraulic diameter?
Yes, yes, sure. Oh, I have some, I think, literature about that. Your hydraulic diameter and all. Right. Here you can see the hydraulic radius and diameter. Okay. I will come later. Right. First, me discuss about this.
Okay, sir.
We have on this. This is very very important concept. Hydraulic diameter and radius. So we'll see these things also. So classification of open channel flow. Basically, the we have lots of definition. On that basis, we classify the open channel flow. Whether it is, sometimes people classified as per our requirement, we classified the open channel, the unsteady flow, steady flow. This is one classification. Another classification, uniform flow and non-uniform flow. This is the another classification. Or one dimensional flow, two dimensional flow, and three dimensional flow. This is the another classification. Or whether it is subcritical, supercritical, or critical, which type of flow. This is also the way of classification. And you know already the steady and unsteady, you have a lot of study about it, where which what are the condition of steady flow and what are the condition of unsteady flow, and uniform, non-uniform, you know already. So here we'll more focus on the classification of open channel based on the Froude number, you know already the Froude number what is. We'll discuss, I have regarding the PPT Froude number, we'll discuss later. So as I was said, the uniform flow and varied flow, you know already the definition of uniform and varied. For just for you, let me read. The flow in open channel is also classified as being uniform and non-uniform. Non-uniform is also called the varied flow, right? Depending on how the flow depth y, that is the flow depth y, the distance from the free surface from from the bottom of the channel measured in the vertical direction, that is the known as the flow depth. Flow depth definition is what? The distance of the free surface from the bottom of channel measured in the vertical direction, not inclined, and measured in the vertical direction. So this is the definition of flow depth. So the flow
It is
depth,
measured from top, sir. It is measured from top, top of the, like, from this top
yeah,
of the tube. Yeah.
yes, you top from bottom, whether you will, if you want to measure from bottom, then you can measure. No problem. If, oh, let me tell, if water is flowing like that,
It makes difference. It makes difference in the case of when you fraud number when we define, then I think it matters where you measure from.
okay, okay, no problem. But for you, now, just what I got you asking, whether you measure from here to here, the same you will get the distance, and whether you start from measuring here to here, you will get the same distance. There is no problem. Just for here retain only the distance from the free surface, and you can also tell the distance from the bottom to free surface. This is the flow depth measured vertically, right? So now the flow in channel is said to be uniform if the flow depth remain constant. Flow depth means what? Your average velocity, right? You always remember your depth is associated with the velocity, you know already. If your here what is written, the flow in the open channel is said to be uniform if the flow depth remain constant. Okay, that is the your average velocity condition. Otherwise, the flow is said to be non-uniform or varied. Okay. The laminar turbulent, you know already what is laminar and turbulent. Basically, in the open channel, in case of the pipe flow, how we will define the Reynolds number? Reynolds number is the ratio of rho and average velocity in the pipe. And let me write here average velocity in the pipe and the rho of the fluid into diameter of pipe divided by your dynamic viscosity of the pipe. So this is the case of pipe, but here the things is changed. In case of open channel, in case of open channel, you will define the Reynolds number like rho, that is rho of fluid, whatever, and your velocity, average velocity in the channel, and your RH. Here the things is change. So RH means what? RS here represent the your hydraulic radius. We have, so in this case this is the whole idea. And you know here the what is uniform flow, gradually varied flow, rapid varied flow. If you see here, the depth was that much, and just within the short length your depth is changes rapidly. So rapid varied flow, gradually varied flow, then your uniform flow. Here also the uniform flow if you see. Now coming on this, your
Uh,
hydraulic radius.
this formula rho v RH by mu, it is valid for only varied flow or all type of open channel flow.
No,
Generally,
this, yeah,
rho v,
this formula is a open channel. This is applicable for the open channel flow.
so then rho v L by mu we call it, isn't it? Rho v L. In case of RH, we generally take L.
Okay, oh, no, no problem. You can represent with this. Let me see rho VL. We'll see rho VL also. What is you telling? Before that, we just learned this concept, the hydraulic radius concept and the hydraulic diameter concept. Basically what is the relation, and based on that we define the Reynolds number in case of the open channel flow, and we correlate with Reynolds number with open channel in case of open channel or in case of pipe flow, how it is correlated with each other. So let me, and here what was the Reynolds number was there, Re, let me write here, Re is equal to your velocity, rho of fluid into average velocity into your RH and divide by mu. And you can also, you know, the kinematic viscosity is mu by rho. So here you can write also average velocity into RH divided by mu. So here it is written V is your average velocity, nu is the kinematic viscosity, and RH is your hydraulic radius. Okay, as and hydraulic radius is what? Hydraulic radius is nothing but RH is equal to area of cross section and your perimeter. This is the RH, hydraulic radius. Now, what is written just for your understanding, considering the open channels, considering the open channel come with rather irregular cross section, the hydraulic radius serves as the characteristics dimension and brings uniformity to the treatment of open channel. This is just for written. Your hydraulic radius is what? Hydraulic radius is your function of, that is your dimension of the channel. This is nothing but also the Reynolds number is constant for an entire uniform cross section. Basically, what we do, we calculate the Reynolds number for the particular cross section, not for the entire. If your channel is like that, we're looking from the top view. If your channel is like that, or you can say if your channel is like, if you take the, here is width is something, here width is something, here width is very very wide. So Reynolds number, if you want to calculate at a Reynolds number, you can calculate at a particular
So,
cross section. For this cross section, yes,
in the case of radius, the area of cross section means the area of cross section of that water occupied area or the channel area.
area of cross section is weighted area. What we have calculated in the previous question, that is the area.
I mean the area that water has occupied till
Yes,
the
yes, weighted area.
not the full cross section
No, no,
of the
no,
channel.
no, no, no. That is
Okay.
not.
And P is actually the wetted perimeter.
Weighted
Okay.
perimeter here. So what is actually mean? You need to if your channel is varying width and depth along the length of the channel or river, so Reynolds number at every cross section, it will be changed because the depth and perimeter or area, you can say, it is varying. In case of this, let's for your simplicity, if you calculated the Reynolds number at that section R1, let's suppose the Reynolds number is R1 here. So here, not here, this is not. So your Reynolds number will be the R1 at every places. But if you calculate here, your Reynolds number is not equal to R1. So it will be the change. So your Reynolds number is a function of, you can say, Reynolds number you can calculate for what? At a particular cross section. And one thing is very very important. Let me tell about Reynolds number. These things is very very important. Actually, Reynolds number, what is represent? I want to go through the dimension analysis. Your Reynolds number is represent what? This is velocity is meter per second. This is your hydraulic radius, or whether D or L, whatever you are telling. This is meter. And this is the kinematic viscosity. This is what? Meter square per second. If you see these things, if we write this equation like your RH, let me put it here, M, and this whole part I want to put it below. There is no change, I think. You know already, if we write this like that, mu by v average. There is no change, you know already. There is no change after the after simplify this, we will again go up. So if you write these things below, meter square per second divided by meter per second, what will happen? Second is cancel and meter square 1 meter is cancelled. So what is happening? Meter by meter. So your represent, that is your Reynolds number is what? It is actually in the numerator and denominator, it having the meter component and it having the meter component from numerator and the denominator. So you can tell also, or this is Reynolds number is a pure length problem. So this is one kind of important thing. And why this is important length parameter? In case of when you study the open channel flow, you know already when you go in the turbulent flow, there is a lots of, in case of turbulent flow, you know the Prandtl, we have discussed about the Prandtl theory. So what was and Prandtl theory, we see your velocity in the case of turbulent flow very thin layer, it is very the linear, then after it is logarithmic vary, right? In case of logarithmic flow, what was your equation? U by U star equal to 1 by, that is a kappa, you can say the von Karman constant, and your y, ln y actually, and plus some constant. So for non-dimensionalize these things, we need one length parameter. For that we need length parameter, and that length parameter was the roughness of your channel. Let's suppose your roughness of the channel is epsilon, or you can say, let's suppose epsilon of your roughness of the channel. So this equation be non-dimensionalized by one roughness channel, or one your roughness of the channel. Sometimes if your, sometimes it is dimensionalized, non-dimensionalized with the your uh, using this your kinematic viscosity divided by velocity. Sometimes it is also used for non-dimensionalize this equation. So this is the whole idea why we exploring the Reynolds number, much about the why it is the length parameter. So when you go in the deeper in case of the open channel flow or whether turbulent flow, this type of concept is there. So now we coming on the topic. No problem. So hydraulic radius concept is also here. You might, let me read, you might expect the hydraulic radius would be defined as a half of hydraulic diameter. So this is the confusion kind of thing. Hydraulic radius, you know the hydraulic radius and diameter by the your basic definition. Your diameter radius is what? That is the half of your diameter. So by the basic definition, but here is the only not radius. Hydraulic term is associated with your radius or diameter. So this is not like that. So it is written here. This is unfortunately not the case. Not the case means your hydraulic diameter not like the half of your that is the two times of the hydraulic radius or half of your these things. Now what is, recall that the hydraulic diameter dh for the pipe flow is defined as the 4 AC by P. For hydraulic diameter we defined these things 4 AC by P, right? So if you calculate these things, let me write on the next. Here your hydraulic radius is what? Let me represent hydraulic radius by area of cross section and perimeter. Here all we are talking about the weighted, right? And your diameter thing. Let's suppose the hydraulic diameter. So this is your 4 AC by P. And for your proofing, let me check for the cross circular thing. Your AC is what? If the pipe flow is there, pi by 4 into d square, and your perimeter is what? 2 pi r, or you can say the pi t. Put it here. 4 AC is equal to pi by 4 d square divided by pi t. Pi cancel. So your d is remaining. So hydraulic diameter is, this is the correct definition. And hydraulic radius is this. If you correlate these things, what you will see, your dh is equal to 4 times AC by P, and your 4 AC, that is the RH. So your dh is equal to, that is your hydraulic diameter of 4 times of your hydraulic radius. So you always remember, this is not your simply radius or diameter case, this is the hydraulic radius or diameter case. So from here you know the relationship for pipe flow. What was your definition of Reynolds number? For pipe flow it was your RH, let me write, that is the V average into dh, hydraulic diameter, divided by your kinematic viscosity. Let's suppose water is flowing in both cases. In case of pipe flow and open channel flow, water is flowing and the velocity is same, no issue. Pure velocity is same, average velocity is same, and dynamic viscosity, if water is, you know, the same. What will happen in case of open channel flow? Your RE is, let's suppose for case of laminar, in case of RE, and I want to write here the open channel flow, V average into DH is what? 4 times of, if you put here, not, let me first write the RH divided by your dynamic viscosity. So this is the your, but when you compare your for laminar case, in case of pipe flow, what will happen? Your Reynolds number equal to, let's suppose 2000, somewhere written the 2100. Here we are considering the 2000 in case of laminar flow. For pipe flow, and if everything is same, your RE is function of what? Only everything is constant. Let's suppose the constant C is here, but what is remaining? That is your DH is remaining. If you compare these things for open channel flow, your at the place of DH, what you will write? Let me, RE for open channel flow, what is V average into RH divided by mu, and this value, if you write here, V average into RH is equal to what? RH is equal to DH by 4. DH by 4 divided by nu. This is not DH by 4 nu. For DH, for these things, your value is how much? 2000 divided by 4, it will come on 500. So this is the relation between the pipe flow Reynolds number and your a Reynolds number in case of open channel flow. So this is the 4 times less. So you can say your Reynolds number in case of pipe or Reynolds number in case of open channel flow is equal to Reynolds number in pipe divided by 4. So this is your relation. So hope I think you understand how it will 4 times lesser than Reynolds number as compared to when you compare the pressurized flow or pipe flow. So this is the whole idea. In the I think in the below section it is written very clearly. Your RE if less than equal to 500, that is for laminar case. Here it is written the flow is laminar for RE is equal to greater than equal to for pipe flow, but RE less than equal to 500 in case of open channel flow, and here the 500 greater than somewhere 4000 is taking in case of your turbulent flow. Uh, Also open channel flow is usually turbulent for 2500 and transition between the 500 to 2500. So this is the whole idea of the that is your open channel flow Reynolds number. One important line is very important line is here. This is the paragraph is very important and you can think about it. The kinematic viscosity of water at 20 degrees Celsius is 1 into 10 to the power 6 meter square per second. You know, and the average flow velocity in open channel is usually 0. Not always, usually 0.5 meter per second. Also, the hydraulic radius is usually greater than 1 meter. Therefore, Reynolds number associated with water flow in the open channel is typically above always 50,000, above 50,000. Thus, the flow is almost always turbulent in case of open channel flow. Always. Okay, I think you got it. Uh, Pradeep and Francis and one student is also joined. The Pala.
So, sir, for laminar flow, RE is 500 in case of open channel flow,
Yes,
2000 in case of pipe flow.
pipe flow. Because the relation what I have tell you, the relation is that the in case Reynolds number in case of open channel flow is equal to the Reynolds number in case of pipe flow divided by 4. This is the almost equal. And you also know the concept, very important concept, hydraulic radius. And one question may be framed like that, the relation between the hydraulic radius and hydraulic diameter. You always remember these things. So now coming on the next. Okay, the fruit number you always know. I have tell you the we can define, we can classify actually the flow on the basis of fruit number also, the subcritical flow, critical flow and the supercritical flow. The definition of fruit number is this. It is actually the ratio of what? V square, that is a V by root GLC. And what is LC? It is the characteristics length. G is the gravitational acceleration. V is the average liquid velocity at a cross section. And F and your LC is the characteristics length. And LC is taken to be the flow depth Y for a wide channel. For wide channel, your LC is equal to Y. Sometimes LC is defined as your, I think, area by top width. We'll see later. Your LC is defined like that, I think. We'll see. Because if you define like that, what will happen? Let me check. If it is the wide case, area is B into Y, and if wide case, we neglect these things. Yes, else is you can define this area by top width also. So for wide channel, your formula will become like that. It is written V by Gy. The Froude number is important parameter for govern the character of flow in the open channel. So generally in open channel flow, we focused on that, whether your subcritical flow, supercritical flow or critical flow. Generally in the hilly region, very steep gradient, generally we can see the subcritical flow, that is supercritical flow, and in the plain area we generally see the subcritical flow. Now we move on the
Sorry,
specific.
just one question. So
Okay.
here this for wide channel,
Yes.
LC is equal to Y.
Yes, LC is equal to Y. You can consider for wide channel.
Okay.
Yes. Now we'll move on the specific energy concept. What is specific energy?
Excuse me, sir. Excuse me, sir.
Yes, yes.
How could we say this channel is wide? On what basis the channel is considered as a wide?
Okay, you join later. I have discussed these things. Okay, I will again tell you. These things I have tell you when we tell the wide channel, and this is the lots of definition is there. But as per the Vanoni, what Vanoni was telling, your if your B is greater than 4 times of Y, that is the 4 times of Y, you can consider this channel is wide channel, right? Or in general, as a layman point of view, if your width is greater than your, if your width is greater than your depth of the channel, then you can also consider it is a, but for a layman point of view, not for the engineering point of view, you cannot say these things. And lots of definition is there. If you want to more explore on that wide channel concept, then you can go through this, lots of literature is there and books also there. So but I know the this one very actually we practically we use this definition. The B is greater than, if 4 times of Y, then we can consider the wide channel. If at a problem point of view, like gate question and another question, in the question is simply was written this is the wide channel, there is no issue. So I think you got it.
Yes, sir, I got it.
Okay, now we'll, okay, here is also very important one thing. Let me tell you whether I have put it or not. Okay, I have not put it here, but I want to tell you. The your Froude number is what? Actually, it is square ratio of what? Your inertia force divided by your gravitational force, gravity force, let's say. So this is also definition. But here the F square, not not only F. F square is equal to these things. If you calculate from here, you can multiply both things rho V, here also rho V, and if you both side square root, what will happen? Fr is equal to Fr square is equal to, if you are squaring both side, your after squaring, actually I want to multiply these things. Firstly square these things, then you will get the v square by, not root is not there, gy only. So let me write on the another. Okay, your Fr is equal to what? Fr square is equal to v by gy, and you multiply this thing, rho g, your v square is here. So this is your represent the actually inertia force. Inertia force. Inertia means nothing but, inertia is your, inertia force is the force due to your mass of liquid and the velocity of liquid, or you can say the dynamic force also. Inertia force is the nothing but the dynamic force, and this is your gravitational force. So like that we also represent the your fruit number. Now the specific energy, very important concept in case of open channel flow. Before we going on that topic, we will let us solve some problem. So here the problem is there. The question number 3. The flow characteristics of open channel do not change with time at a point, and what type of flow is it? Actually the option 4 is there: uniform flow, non-uniform flow, steady flow, and unsteady flow. Before, I think I have discussed about it, the classification of flow based on the uniform and unsteady, steady kind of thing. The question is this: if it is open channel flow, actually I am looking from side view. If open channel flow is there and I want to measure velocity at a particular point here, if at a particular point, let me write your, at 8 p.m. your velocity was 1 meter, 9 p.m. also velocity was 1 meter, 10 p.m. velocity at a particular point, your velocity was 1 meter per second actually. So actually which type of flow this is? Please write your answer in the comment box. This is a very basic question, but understanding is very important what question is telling.
Steady flow.
Yes, it is a steady flow, and if your velocity is not changing with along, if you measuring the velocity along the channel, and if your velocity is not changing with respect to length or with respect to a space, you can tell, then such type of flow is known as a uniform flow. So the another question is there, the question number 4: a specific energy of a flowing water in a rectangular channel of 5-meter wide, 2-meter water depth, and discharge this. So you need to calculate this specific energy. So please just calculate and write your answer in the chat box. This is a very simple question, but it is very important. Please solve this question, and after this question we'll take some 5-minute break. So as you all know the specific energy, and we will discuss about the specific energy and all. First you write based on your classes, you just write the answer of this question. For question number 4, what is your answer? Please write, and you can calculate. Okay, Pradeep is telling the option A is correct. Within or 1 or 2 minutes, just write your answer. Then I will discuss about it.
The answer is option A.
Yes, option A is correct. You know the specific energy. Let me write on the. Yes, your actually the specific energy is what? E is equal to Y plus
Q square by G to the power of 1 by 3.
2Z. Okay. 1 by 3, what you are telling?
Sorry.
No, nothing like that. Okay. Your specific energy, if you represent the energy by E, these things, and Y is equal to how much? Y is equal to water depth, 2 meter,
2.
and your velocity, you know already, your discharge is equal to what? Area into velocity. So if you calculate the your velocity and discharge by area, how much discharge is 10 meter cube per second, and your area is 2 meter your depth and 5 meter your width, then 1 meter per second. And if you will put here 2 meter and 1 meter square and 2 into 9.81, what will happen? 2.05 your the answer of this question, and the unit is meter. I think unit is not written here, so you need to write the unit always. So we'll take the 5 minute break, then we'll meet on, I think here 7 3 is there. We'll meet on the 7:10.
Okay, so thank you.
ಗೋಬಿ ಕವರ್ ಹಾಕಿ ಎತ್ತಿಡ ಬಿಸಾಕ ಡಸ್ಟ್ಬಿನ್ ಹಾಕೋ ಎಷ್ಟು ಪೇ ಮಾಡೋದು
Hello? Yeah, I'm audible.
Yes, sir.
Oh, okay, okay. Now will I think I have some another one question is here if the depth of water in the open channel flow is less than the critical depth, the flow is known as what? Your torrential flow and the tranquil flow, critical flow, or the turbulent flow. Just please write your answer. Which type of flow is this? The flow depth in the water in an open channel flow is less than the critical depth. Because here the option is like that in case of when your depth is greater than your critical depth, in that case we say the your flow is this, the tranquil flow or subcritical flow. But in case of your depth, what is written here, your open channel flow, your depth is, that is the critical depth, or you can say the normal depth. Normal depth is less than the critical depth. So this is not the case of turbulent flow, not the case of critical flow, not the case of the tranquil flow, only the torrential flow, or you can say the supercritical flow. This is a supercritical flow.
So supercritical means it is turbulent flow, is it not?
Huh?
The supercritical means it must be turbulent flow, is it not?
No, no. In case of open turbulent flow is the another definition. Just I have tell in the previous slides. Your turbulent flow is related with your Reynolds number, right? In case of turbulent, not only Reynolds number, but one parameter is the Reynolds number. If it is greater than 2,500, or you say the 2,000, so it is a turbulent flow. So that was the
So,
definition.
so supercritical means Froude number will be more than one, is it not? So in supercritical.
Yes, in case of the supercritical flow, your Froude number is greater than 1.
So in this case, in the other side, the depth of the uh, channel. Yeah.
Actually, I want to tell you, just in the previous slides, what we have studied, what we have seen, I was tell it is very important line or very important segment. What was I was telling? Yes, here if you just see the kinematic viscosity of water at 20 degrees Celsius is this. This is always fixed, and your only velocity and your hydraulic radius. This is control the your Reynolds number. If your mu is kinematic viscosity is constant. In case of generally practical flow, your mu is constant. So always when you calculate, typically your value is come in the range of this 550,000. So always in practical flow, always the flow is turbulent, not laminar. And your this critical flow also, critical flow is in the practical case not you can see anywhere, and uniform flow also you cannot see anywhere in the practical case, unless you will design such type of flow. In naturally it's not possible. So we'll see the specific energy concept. Actually, what is a specific energy? So actually the specific energy, let's suppose this is the channel is flowing.
Sir, one question, sir. For so
Yes.
so if the flow depth is less than critical depth, critical flow depth, it is called tranquil flow. You can say subcritical flow,
Yes, subcritical flow we know the tranquil flow.
tranquil flow. So if depth is less than critical depth, then tranquil flow. Yeah.
No, let me go again of the question. Question this one.
Yeah, depth
The
of
depth of water in the open channel flow is less than. Let's suppose depth of flow is this one, and your question is asking this thing. If your depth of flow is less than YC, that is your critical depth. So which type of flow? That is the torrential flow, right? This option is correct for that, right? If your flow was like that, your YC here Y1, it is greater than like that, then your this is the case, right? Are you getting?
the flow depth will measure from top of the floor, is it not? Not from the bottom
Yes,
of
from the
that.
top or bottom you can measure, no problem. You need to reach. If you start measuring from here, you need to reach at that point. If you are starting measuring from here, you need to reach at that point. So whether you measure from top to bottom or bottom to top, there is your all depth will be definitely same. Okay, we'll
Yes.
move. One important table is here also, the types of hydraulic jump. You all know the concept of hydraulic jump. Let me tell some important table. If your fluid number is varying, they come under this category. This is the angular flow or the undulating type of flow. This type of question sometimes asking in the some competitive exam, if a fluid number is lies between this, then what type of jump, weak jump, what type of water surface profile, that is the small rollers formation. If it is come 2.5 to 4.5 range, then oscillating type of jump, and water oscillating in the random manner. If 4.5 to 9, your steady type of jump, and roll and jump action you can see in the water surface. If it is greater than 12, what will happen? Your jump will be strong and very smooth and choppy type of water surface. If you are not aware in this any terminology, you just Google and see the image what is mean of rolls, jump action, choppy, this kind of thing. Just Google. Oh, let me come back on the specific energy. Basically, specific energy, let us consider one channel here. This is the open channel case, open channel flow. And datum, that is a reference datum, is considered at that point. And this is the depth of flow. Y represent the depth of flow. Okay. So whole energy, the total energy is what? You know the from the Bernoulli's equation is what? Y, that is your datum head from the where you are considering the datum, it depend on that only. And your P by rho g, that is your pressure head, or V square by 2g, this is your velocity head, or you can say the kinematic head, or sometimes the dynamic head also. So in case of open channel flow, your P by rho g is what? Y. If you insert the piezometer at that point, so you will get the height of only this much in the piezometer. So your P by rho g is Y in this case. The total energy is expressed in the 13.7 equation is not a realistic representation of the true energy of the flowing fluid, since the choice of reference datum and thus the value of elevation head, that is Z, is rather arbitrary. Why it is not representing the actual energy? Because of, if you shift like that your reference here, your datum will be reduced. So here the magnitude of H will be changed. So this is not, because one thing is fluctuating, it's depend on you where you will choose, where you will select the reference datum. So it is not an actual energy kind of thing. So what is written, let me read. The realistic, it is not represent the realistic representation of the true energy of the flowing fluid, since the choice of reference datum and thus the value of elevation head, that is Z, is rather arbitrary. Yes, definitely. And the intrinsic energy of a fluid at a cross section is represented more realistic if the reference datum is taken to be bottom of the channel, so Z is equal to 0. If somehow we do the Z is equal to 0, then we can easily represent the realistic energy, what, how much energy having the your flowing fluid. So this is the whole idea why we neglect the Z in case of specific energy, you know already, or by definition by this analogy, you know. Then the total mechanical energy of the liquid of the fluid in term of head become the sum of pressure and the dynamic head. This is the sum of your pressure head and the dynamic head. The sum of pressure and dynamic head of a liquid in the open channel is called the specific energy. It is called the specific energy. and is expressed as like that. Es is equal to what we have just before we solve one question on that, v square by 2c. So why we neglect the z, you I think already know. For the realistic representation of the energy in the flowing fluid, for that reason we neglect the datum head from this equation. So it is very very important concept. Sometimes people is asking why we neglect, why we actually not consider the datum point in case of the open channel flow. The actual, the correct answer is this: for the realistic representation of your energy in the flowing fluid. So actually, and we have one graphical representation of your, here the two, this is represent your, and this is your parabola kind of thing, and this is the straight line kind of thing. So combined of these things we got this thing, or we got this type of profile. If you want to the more explore on the specific energy, basically for this diagram we got actually the three y root. So one is, this is the negative root, so we neglect that thing. And what I am telling, if you want to more explore on that, sometimes people also asking about this, how many roots we got actually in case of when we solve the this energy concept and all. So we got the three, but one is negative, so we neglect one, and we generally focus on two depth, that is the physically possible. And at the x-axis this graph is having the es, that is your specific energy, and at the y-axis your graph is having the depth of the flow in the channel. If you draw one, let's suppose if you draw one line here, that is a specific energy, let's suppose E1 at that place. For E1 you got the two depth. For E1 you got two depth. What? Let's suppose this is represent Y1 and this is represent Y2. So you got Y1 and Y2 in case of your for a single your specific energy, for single value of a specific energy you got the two. And this middle point for a specific energy, for a single specific energy you will got only one point. So this is one point, and this point, that is the depth up to that point, is known as the critical depth. So from here we just defined, if your water is flowing above the critical depth, that is your subcritical case, and if your water is flowing below the, so it is your supercritical case. And on that we have one example. So let me go on the example first, then you will clear more. I think question number, yes, here if you see the question number 9, just you please solve this question number 9, then this concept will, just to solve and write your answer in the chat box. Question number 9 in a
Little bigger, sir. Can you larger if possible?
oh, it is not visible.
Not clearly,
Oh,
sir.
okay, just a bit only. This formula we will use in some question, another question. So
Yes,
now it is visible.
yes, yes, yes.
Okay, and let me read, no problem. In a rectangular channel, the channel is rectangular type. The depth of flow is 1.6 meter. Depth of flow is 1.6 meter, and specific gravity at a section is 2.7 meter. Specific gravity is given 2.7 meter. Then the flow condition is what? You know already. In case of rectangular channel, what is the formula of a specific energy? relation with the your critical depth. From here you calculate the critical depth and compare this depth, whether it is less than critical depth, whether it is greater than critical depth. On that basis you tell whether option A, B, C, which option is correct. Just please. So this is a very basic or important question. Some such type of question you can expect in GATE. 1 marks question is. Let me also try to solve this question. Channel depth is how much? Y is equal to 1.6 meter, right? And a specific energy is given, that is specific energy 2.7 meter.
So velocity is coming 4.65. So velocity is
Okay, and from velocity you can calculate this your fruits number.
yes.
So which option is correct for this question? Whether critical, subcritical, or supercritical, and also none of this.
The supercritical.
Yeah, I think it is supercritical. Let me check. So you know the formula of specific energy I was telling. E is equal to what? Y plus V square by 2G. So E is what? How much? 2.7 plus y is how much? 1.6 not plus equal to 1.6 plus b square by 2 into 9.81. Here how much? The 2.7 minus 1.6 into 2 into 9.81 or root under of. You can calculate v. How much v? 4 point
No, 6.5.
meter per second. From here you know the fr well, v square, that is v by root gy 4.56 divided by 9.81.
6.5.
Here it is not written the whether the rectangular channel, whether the wide or narrow, but the another data is also not given here. So you just uh, by your lots of the assumption kind of thing. So if your width is not given, you just consider this data was given for wide channel 1.6 meter. So it is, I think, how much? Less than 1, but less than and
So
1.
1.17, sir. 1.17.
1 point
17. It is 4.65. Yeah.
1
7.
4.65, right? 1 point.
17.
So it is greater than 1, and
Yeah.
you know already the FR, if greater than 1, it is a supercritical kind of thing. Okay, so this is the correct way of solving. Sometimes people also solving like that. What I was telling before, this specific energy E is equal to 2.7. So sometimes people considering this EC is equal to 2.7 is given, is equal to, if rectangular channel is given, you know these things. If you will calculate from here, your EC is how much? 0.9 divided by 2, not into 2, not. So it is 1.8 meter. So if your YC is here, YC and yn is your normal depth is given y 1.6, your yn is less than yc, and what will happen, it is also given the supercritical flow. So but this is not a correct way, because here not written the whether it is critical and what. So this is the correct way of solving this question. Okay, so this is that. And for question number 10, I will tell some very important kind of thing about the Manning's velocity formula. Before question number 10, we'll solve another question number 7 and 8. Yes, question number 7 is telling, I think not visible, let me. Okay, I think now it is visible.
Yes, sir.
The depth of water below the spillway and after the jump are 1 meter and 6 meter respectively. The head loss will be how much? So head loss formula you know already, the relation with the your depth. And one question in this open channel flow is very important. You know, I think alternate depth concept, a kind of thing. So at a same what I was telling previous, at a particular specific energy, your two depth is there. One is the in case of in the subcritical zone, and another one in the supercritical. So such depth is known as the alternate depth. And at a particular, I think, specific energy, which at a particular specific force, actually there is two depth, and which That depth is known as by another name. Just you write your answer in the chat box. Such type of uh, that is your depth is known as by which name? Just to write in the chat box. For question number 7, which option is correct?
So A is
Yes,
sorry, yeah, A.
yes. What you are telling, Pradeep?
A will not be there, sir. 5 meter. 6 minus 1 is equal to 5.
Okay, okay. Let me check. I will also solve this question. And at a particular specific force, there is two type of depth, and that depth is known as by your secant depth or conjugate depth. You always remember. And at a particular specific energy, the two depth which is known as your alternate
Conjugate,
depth.
alternate depth, yes, sir.
Such type of questions sometimes I have seen in some another in various examination. So okay, for this question one formula is there. What was the previous one formula? This formula. If you solve this question by this formula, then you will definitely get the correct answer. Let me just for you.
But sir, V is not the keyword. V is not there, so that is the problem actually. Yeah.
Here is
Right.
the formula of the energy loss is this. EL is equal to Y2 minus Y1 whole cube divided by 4 Y1 Y2. So your basically 6 minus 1 cube divided by this formula is very important. Sometimes directly question and y2 is 6. So here 5 to the power cube divided by 24. So 125 divided by 24, it will come 5.2. So option A is given. I think your answer was correct. So option A is correct for this question number 7. Similarly, the question number 8 is given. If you will try to solve the question number 8, in the open channel flow, for the best efficiency for a rectangular section, the ratio of bottom width to depth shall be. This is a direct question. Most efficient channel. For the most efficient channel, for just for sake of your understanding, because you know the for making the channel, it is mostly cost expend in the perimeter. So if your perimeter is minimum for a particular discharge, so that type of that dimension of the a particular channel will be the most efficient, or sometimes most economical, people are telling. So if you know, just I want to take one example of rectangular channel. Here rectangular channel is given. It is B, that is the your width of your channel, and this is Y. So the ratio for the most economical channel, I think B is equal to 2Y. This is the condition. Anyone know?
No, sir, but it is good. It is good that you do this. Yeah.
Just you please. I think this topic is covered in your NPTEL class.
Sir, not this particular thing, sir. Yeah, I think it is said, the sir said something, but not exactly this way.
Okay, okay. But it is very important for your examination.
Yeah, he did discuss. He discussed about this. Yes.
Okay. So I think if discuss whether this condition is correct or not, just please.
So you want to say two, sir? Two is the answer.
I think 2 is the correct answer. You know, everyone, for the most efficient channel, your hydraulic radius is equal to Y by 2. From here, this is a very well known. So for rectangular channel, so this is the area by perimeter. Y by 2, area is how much? B into Y divided by 2Y plus B, not Y by 2. From here it is cancelled. So 2B is equal to 2Y plus B. So B is equal to your 2Y. So this is the correct. B by Y ratio is equal to 2. In this question, what is asking? The ratio of bottom width to depth. This is correct too. If sometimes question may be the reverse side, your depth by bottom width, that is a 0.5. So you always need to read the question is very well. So this is the question number 8, and we have solved the question number 9. Now we come on the question number 10. I think I have some another
So, sir,
concept
the
for you.
answer is two, is it not? In that case,
Yes,
the answer is two here. The
yes,
previous,
answer is 2 here.
right? Okay.
Now I think I have some concept for you also. So not this is only the conversion things. At the place of your velocity, we put the discharge in terms of discharge. Actually, in this book, actually discharge is represented by V. Generally, we represent the discharge in. Don't confuse. So for the critical things, yeah, one thing is also important in case of your Froude number. Let me discuss. Then we'll move on the question number 10. Your Froude number, this Fr is equal to what? Your velocity of, that is the average velocity of flowing fluid and this is all, and this velocity is, that is the c dot is the gy, this is the wave velocity represented by the wave velocity, your gy. So you always need to remember these things. Sometimes question on that formula also framed, so you always remember this concept. Sometimes in case of supercritical flow, subcritical flow, which one will be the greater? If you want to the your fr should be greater than 1, then what we will do? Fr should be greater than 1 means what? Your velocity, that is your flow velocity, should be greater than c naught, then only fr will be the greater than 1, right? If fr is greater than 1, then your critical, that is your supercritical flow. If you want to the your fr should be the less than 1, your velocity should be the less than 0, right? So I think you know already about it. And wave celerity, this is also known as the wave celerity, is c naught. And whether your wave, if you, let us suppose water is flowing in this direction and you want to check the flowing fluid in the channel, whether it is subcritical or supercritical, so just dropping one stone in the channel, and if here you just see, if your, in the case of supercritical flow, that is your velocity is greater than c, that is your, what was the magnitude of c, it will be the less. So there is no chance to move in that direction of, in the still water. If in the pond, if you throw one stone, then what will happen? Both side your wave is propagate. But in the flowing water, this is not the case. In flowing water, if your velocity is greater than your c, then what will, your wave is propagate in this direction, not in the upper direction. And just opposite in case of the subcritical flow. So by throwing your stone in the channel, you just qualitatively you can say this is the subcritical flow or supercritical flow. So I think this is very important. Now coming on the last question, question number 10. You people solve the question number 10, then I will discuss some constraint about your Manning's equation. First, you need to solve this question and write your answer in the chat box. A 1.2 meter wide rectangular channel of bed slope is given 0.0004 and Manning's coefficient 0.01, carrying the discharge of 0.5 meter cube per second. The normal depth of the channel is what? So here Manning coefficient is there. So I just you remember the concept of where we use the Manning coefficient, and you know the formula also. For question number 10, which option is correct? You know that your V is equal to is 1 by n r to the power 2 by 3 s to the power 1 by 2. And in the question is given what type of information? Wide rectangular channel is given, so r is equal to y, you know already. So this formula is modified like that. Your here velocity is given. If you multiply area this side, this will come on discharge form. So 1 by n y to the power 2 by 3 y into b s to the power 1 by 2. So your q is given 0.5, that is your discharge, 0.5 meter cube per second. This is given 0.1 and y power 2 by 3 and power 1 is here. So 2 by 3 plus 1, how much? That is your 5 by 3. Into b is given 1.2 meter and s is how much? 0.0004 to the power half. So your y is equal to how much? 0.5 into 0.01 divided by 1.2 divided by 0.0004 to the power
One. I think it is one, sir.
0.5. How much?
It's coming point one, sir. I think, but there's something wrong. Oh, it must be one. Well, it is coming one.
Okay, power is 3 by 5. How much you are getting?
So I have not any mistake. I have not done by B. B I have not multiplied.
Okay.
Yeah.
So your 0.5 into 0.01 divided by 1.2 into 0. Or you can say the 0.5 power, and the whole power is 3 by 5. Now you
I think,
calculate.
sir, 1.2 is not required. I think, sir, 1.2 is not required. I think. Yes, are they 1.2 as a right? Okay.
It is 1.2, or I think 1.2 is the
Yeah, right. 1.2. Yes. Yeah.
0.5 into 0.01 divided by 1.2 into 0.0004 to the power 0.5 whole power how much? 3 by 5. Answer is coming your 0. Something like that, 0.4. You people also getting these things? Just to calculate whether I am doing mistake or correct.
So mine is 0.2. Something is wrong, sir. No, I think you may be right. So I'm getting a 0.21, sir. So
0.
my 21, but it may be wrong, sir. You may be
21.
correct.
Okay. Okay, whatever. This is a procedure is this.
Right,
And
sir. Yeah.
if answer is coming 0.4, here
Yes,
is
so
not given the 0.4, but you can go
so
for the best appropriate.
0.5 is 0.5 is there, sir. 0.5 is there. So it is
Yes.
closer. It is closer
For
to 0.
yes. So you can select this one. Such type of mistake is also in the examination kind of thing, but most
So
appropriate you can.
5 by 3 or 2 by 3, sir? The y to the power 5 by 3 or 2 by 3?
Yes, it is 2 by 3 here is given, and 1 is power is here, right? So 2 by 3 and 1. How much? This is the 5 by 3, right? So
Yeah,
that,
5.
yes. So this is come with the combination of these things and these things, right?
Yeah, yeah.
Or maybe some, I think here data was mistakes, and but the
So I don't
procedure
want.
is
Yes,
this.
yes, 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 yes.
Now coming on the main part, or the this your Manning's velocity equation. So this is first, it is the empirical equation. Empirical equation, you know, the empirical means what? It is based on experiment. It is based on experiment, right? It is not as for we are going to calculate things on the basis of mathematics or physics concept. Not, it is based on experiment. This equation was given, but it is more suitable. And in this question, the limitation of this equation is what? If you have your geometry, that is you want to design some canal, then what you will do? You already know the capacity of canal and the slope of the canal, right? So here in this question, if you want to solve the this equation, you need two parameters, your velocity and your uh, for solving this, you need your roughness, Manning's roughness coefficient, and for velocity, also velocity is unknown for this equation. So this equation having two unknown. So this is the limitation of the Manning's equation. For that, for n, what we do, we do the different experiment. We do lots of experiment and find out the value of your n. And if your material, what type of material is there, we just go for the cross reference of the many experiment was done by the different researcher, by the lots of various researcher. So on that basis we consider n, and then we solve the this equation, but not accurate, because in the n value is calculated based on the experimental thing, and which type of material is there, and your in the practical case which type of material is there, you just consider the approximate value of n. If you will consider the approximate value of n, then you will get the your approximate value of velocity. So your Manning's that is your Manning's equation give the approximate velocity of your channel flow and whatever.
So
So this is,
generally, sir, approximate n is 0, 1, sir, 0.01.
yes, experiment n is what? Based on the experiment, based on the experiment, we calculate the n. Let's suppose you are going to design one canal, but in your specific canal or region, your soil type is different type or maybe the another type, but experiment was done on the different type of soil, right? So maybe the n value maybe the differ for that your n and for this one, but we consider the approximate n. Let's suppose the n is similar of these things. If you are approximating your n for this channel, then definitely your velocity will be some approximate, give the approximate answer, not but not that much variation. So this is the constraint of your Manning's equation. So that is the whole discussion was today. So we'll meet again on the next on Friday. That is your some extra classes. Extra in the sense of will on Friday we'll cover on the drag and lift concept. So if you have any question and doubt, you can mail me, and we'll discuss that question also on the coming session. Just I want to write here my mail ID.
So one question, sir, I have. Suppose if we have to know the fluid dynamics of river, we have to define. Now, what are the parameters we need to consider, sir? Yeah.
Okay, just wait.
The next
I
time,
have
sir.
written my mail ID in the chat box.
Yeah,
If anyone asks the question, you just mail me. Yes, so you are asking about one river is there, and
yeah.
you want to what you are want to
Describe the fluid dynamics of the river.
you want to
Describe the fluid dynamics, the entire fluid dynamics of the river.
okay, you want to describe the fluid dynamics, right?
Yeah.
Let's suppose generally if it is a flow, let's suppose you're in the flow heavy high flow condition, that is the flood condition, your river water is spreading in that much area, right? But your river shape is like that. This is right. And you want to study about the hydrodynamic of your river, right? This is your question.
Yes, yes.
So basically you need to first consider initial condition. If you are going to unstudy time, initial conditions, boundary condition. Initial condition is only required when you are going to study the unstudied type of flow, right? Because at a particular time which type of flow is given, then later on how the dynamic will be changed. If your flow is studied, that is the your boundary condition is enough for solving this question. There is lots of software is there. ANSYS, Hackers. In the ANSYS, you just make the geometry of your river and just put the mesh
Can you write
condition.
down? Can you write, sir? You can write, please.
Yes.
Can you write down the software name, sir?
Okay. 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 No. ANSYS, and second one is Hackers, and Delph 3D. Fourth one is these all actually software are used for different purpose, but hydrodynamic study in all this. And another is your open form, and fifth one you can the mic 11, I think mic 11, I think 11 or mic 1, this type of. And another software you can CCHC, I think. I don't remember the exact name, but it is very famous, this software. So just for if you are going to initiate your this hydrodynamic kind of study, you use these things. If you are actually going to study the river, then Hackers is the best for your initial start. Then after, and you can also you can study your hydrodynamic with your own code maybe in C++ or maybe the Fortran. Generally, we use the Fortran for the CFD study. So for your question, the initial condition, boundary condition is required, and mesh, how much you will take the mesh size. This is also important because directly affect your the accuracy of your analysis. So this is the requirement before study the hydrodynamic of your channel.
Okay. Yeah.
Okay, we'll meet on the next session on Friday.
Okay, sir.
Okay,
Thank you,
bye
sir.
bye. Thank you all.